All right, this is the Grandmaster video for surface area. A few critical thinking problems. Number one, a sphere of radius r is cut in half. Derive a formula for calculating the surface area of the resulting hemisphere. So hemisphere just means half a sphere. So derive means, well, come up with yourself a formula for calculating the surface area of this sphere. Okay, so we know the surface area of a complete sphere, but when we cut it in half, well, you should be able to see that we can't just cut the formula in half, because in the process of making the cut, we now have exposed a new flat face here, and we would have to include that. Right, so let's start with the surface area of just a regular, complete sphere. All right, so this face right here, that is just the area of a circle. So I'll just put A equals pi r squared. That's the area of a circle. Okay. However, this, okay, that is going to be half of this. All right, so how do you divide 4 pi r squared by 2? Well, that's easy. All you have to do is divide the 4 by 2, and you get 2. Okay, so the surface area of my hemisphere is going to be 2 pi r squared plus this blue face. That's pi r squared. Okay. You can simplify this formula because, remember, there's an invisible 1 here. And these are like terms. I have 2 pi r squareds, and I have 1 pi r squared. So 2 plus 1 is 3. 3 pi r squared. All right? So the surface area of a sphere cut in half is 3 times pi times the radius squared, because you have to include this cross-sectional face here. Number 2, a solid cone has a radius r1 of 2.5 centimeters. That's right down here. And a slant height of 8 centimeters. So I've labeled that right here. If the top portion of the cone is removed, and you can see I've removed it here, and the resulting smaller radius, r2, right here, is 0.75 centimeters, what is the remaining surface area of the cone? Right? So we just have a regular cone, and I've just effectively chopped the top off. And I want to figure out what is the surface area of what is left over. Okay. Now you might think it's just simple. I just find the surface area of the big cone and then subtract the surface area of the little cone. It doesn't quite work that way. Because remember, the surface area of an object is the sum of all of the areas of the exposed faces. So you really have to be careful. We can't just blindly subtract one from the other. So we're going to be organized. So this is the surface area of the big cone. So this is before the top portion has been removed. There we go. Big cone. Okay, the surface area of any cone is pi times r squared, but we're given the radius r1. So this is 2.5 centimeters. So pi r squared plus pi times r times the slant height, which is 8 centimeters. Okay, so I'll work that out on my calculator. That's pretty easy. So pi times 2.5 squared plus pi times 2.5 times 8. And I get approximately 82.467. Because I'm going to have to work with this number. I'm going to keep a few extra decimals. So this is centimeters squared. Okay. Now before I attempt to solve for the surface area of this little cone, the top piece that's removed, there's something I need to figure out first. Okay. Notice how I have the radius of this little guy, but I don't have the slant height. I kind of need to know that if I want to figure out the surface area of this lateral face that's being removed. Okay? Well, how on earth do I do that? Well, it's a bit tricky, but it involves mathematics that, well, you would have used before. Okay? Because you should have worked with, in the past, similar triangles. And when you're dealing with a cone, okay, like so, you can see that I actually have a couple of right triangles. So I'm going to draw out a right triangle here from the picture. And I'm going to label it. This is 8. I'll leave out the units. And this bottom here, R1, so this is 2.5. Okay. Now I'm trying to figure out this length right here in red. So that's 90 degrees here. So this is S. Okay. But I know this. Okay. That was the bottom radius here. That was R2. So this is 0.75. Okay. Well, if you have a right triangle, and you have a smaller right triangle nested inside, well, it turns out that all of these angles are exactly the same, even though one triangle is larger than the other. This means that the triangles are what we call similar. And a similar triangle, basically you have one triangle that's just a blown up version of the other, which means everything is in proportion. So I'm going to set up a proportion. So I'll keep that in red. I know that the length of S, the ratio of S to this bottom length here, 0.75, that ratio must be equal to the ratio of this long slant height, which is 8, to this length here, 2.5. Okay. So what I've done is I've created a proportion, but now I can actually solve for S. Okay. Yes, you can use cross multiplication, but S is on top. That's what I'm looking for. So really all I need to do is multiply both sides by 0.75, because that will cancel it on the denominator. So 0.75 multiplying, I'll squeeze that in. I'm just treating both sides the same. And then of course these cancel. Okay? So I'm going to get S is equal to 8 divided by 2.5 times 0.75, and you are going to get 2.4. Okay, so that's a length. Of course, we're in centimeters, so I'm going to put the units back. Okay, so I'm going to label this now. So I'll get rid of that S, and I'll label this slant height. It's an ugly arrow. This is 2.4 centimeters. So now I can determine the surface area of the little red cone. So surface area of small cone equals pi times the radius squared plus pi times the radius again times its slant height, which I've calculated as 2.4 centimeters. Now, yes, I can work this out and get one number, but you know what? I'm not even going to bother, because remember, what is the goal? It's to find the surface area of this, well, we call it a truncated cone, I guess, when this top part is removed. But in removing it, I actually create this flat bottom, okay, which is this right here. Here, I'll color code it. So in green, okay, that bottom face is this, okay, and purple, this right here, that is that. Okay, so when I remove this top cone, I'm going to subtract this pinkish purple, but I actually have to add the green because I've exposed a new face. So that's why I just don't want to determine the surface area of the red cone and subtract it from the blue, because that would not give me the right answer. So the final answer, right, it's not just about using formulas, it's about problem solving and thinking and reasoning. It would be 82, because that's the surface area we start with. Okay, so I have the surface area of my large cone. I have to remove this top piece, so I have to remove the purple. So let's put that in purple. So I have to subtract pi times 0.75 times 2.4. Okay, but I have to add this bottom face in green. So I'll put that back. So plus pi times 0.75 centimeters squared. All right. So I'm going to work this out. So 82 minus pi times 0.75. Whoops. 0.467. And I get approximately 78 point, and I'll go to 1 decimal this time, 6. And this is centimeters squared. So this is definitely a tricky problem because there's lots of different steps along the way. But hopefully you can see how I've broken it down and used different colors to help you. You can see why in this case I have to subtract a certain portion, but I have to add on the rest. So 78.6. Finally, number 3, a cubic block of wood of length 12 inches has a cylindrical hole drilled through it. If the hole has a radius of 2 inches, what is the surface area of the block inside and out? Assume the hole is orthogonal to the face of the block. All right, well, first and foremost, what in the world does orthogonal mean? All it means is if you have a block of wood, it's flat on the surface, when you're drilling through it, you're just drilling straight through. So you're not drilling at some funny angle or anything weird like that. It's just going straight into the block. Okay, so that's all we mean by orthogonal. You can also think of it as perpendicular. So nothing fancy there. All right, so this problem is actually very much like the previous problem where we have a large shape, but we're removing some, and we're trying to determine what is the leftover surface area. And hopefully you can tell that this hole is the shape of a cylinder, hence a cylindrical hole. So, like the last problem, I'm going to find the surface area of the block. Okay, this is without the hole drill, so we're just pretending that it's a solid block, nothing's been drilled out. Okay. So how do we find the surface area of a block? Well, it's pretty easy. We're told it's a cube, so it has 6 sides, all of which have the same area. So this is of length 12, therefore this is also 12. Which is nice, 12 inches, and this is 12 inches. Well, if you want to find the area of any of the square faces, you just multiply 12 by itself. But you don't want to multiply by 12 again. That would actually give you the volume. You want to multiply by 6 because there are 6 faces. So it is 6 times 12 inches times 12 inches. So you work that out. That is just 6 times 144, and you get 864 inches squared. Okay. Now, when we drill a hole through it in the shape of a cylinder, you have to think, what surface area are we going to lose, and what surface area are we going to gain? So like before, I'm going to use some colors. So these are going to be holes. Okay, so I'm going to lose those. So that's the area of a circle, and that's the area of a circle. Okay, so those two areas are going to have to be subtracted from this number. Okay, however, right here, this surface here, the lateral surface area of the cylinder, that is now exposed. You could see that if you looked through. Okay, so if we're creating a new surface, we actually have to add that to this number. All right. So the surface area of the cylinder, okay, I'm going to color code that. Put my green back here. That is 2 pi r squared. Remember, it's the 2 because we have the front and the back. Plus, I'll put that, this face here. So that is 2 pi r h. So this green, that is going to be subtracted from the blue, but the purple has to be added to the blue. All right, so I'll put this in black. So final answer, and that's going to be 864 inches squared. Okay. And I have to subtract off the green ends. So that is 2 times pi times the radius of the hole. And what is the radius? 2 inches. Okay. But we have to add on this bit here. So put that back in this color. This is 2 pi, and the radius again is 2 inches, times the height. Okay, well, the height of the cylinder, that's just the length of this hole, which is the length of the cube. So that's just 12 inches. All right? So let's work this out. Okay, so 864 minus 2 times pi times 2 squared plus 2 times pi times 2 times 12. And I get approximately 989.7, and of course this is inches squared. Okay, so quick recap, just find the surface area of the block, and then when you drill the hole, you have to subtract the 2 circular faces, but you have to add this lateral surface area here. That's the 2 pi r h.